All right. Now, what we're going to do is learn about drawing isomers of each other. And so our first goal is to figure out, what does isomer mean? So isomer are molecules that have the same chemical formula, but I like to describe them as having different shapes or orientations. And so if we think about this, let's go through an example of, let's say we're trying to make isomers, two isomers of C3H8O. And so anytime we're drawing isomers in this class, we're always just going to follow the simple ways of drawing molecules or covalent molecules, which is by using honk, right? So every single time we do this, it'll always be with molecules that deal with honk, or 1, 2, 3, and 4 bonds. And so anytime we do this, we could always make these things by predicting a simple molecule that exists that has these elements. And so the base, or the easiest way that I like to do this, is just make a simple chain. So step 1 is to make a chain of elements that can have multiple bonds. And so in this case, we know that carbon can make multiple bonds and oxygen can make multiple bonds, since we have C and O. And so let's make a chain of that. And so in this case, our first molecule, isomer number 1, will have a chain of carbons, 1, 2, 3. And then we have an oxygen at the end to make it really simple. Then step 2 is to add hydrogens until honk is satisfied. Until honk. And so what we have to do is look at each of these individual atoms and make sure that they have the appropriate amount of bonds. And so if we look farthest to the right, this oxygen right here has 1 bond attached to it. And since it's in honk it needs 2, we add 1 hydrogen so that it has 2 bonds. And then we now know that this oxygen is satisfied, so we go to the next element over. This carbon right here has 2 bonds attached to it, and so it needs 2 more bonds, and so we attach 2 more hydrogens. Then we look at the next carbon over, and we see that it has 2 bonds, so it needs 2 more hydrogens. And then lastly, we look at this carbon, the last carbon all the way to the left, and it has 1 bond, and so it needs 3 more. And so we added 3 more hydrogens. And let's see if this actually is our molecule. So we count how many carbons and oxygens and hydrogens we have. We have 1, 2, 3 carbons. We have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens and 1 oxygen. And so we have actually created this molecule really straightforward using this. Then our third step is to add dots or electrons to those that need it, so that they all have 8 electrons each, besides hydrogen. And so in this case, we have to look at each of these elements to make sure that they have 8 electrons around them. The good thing is there's a simple rule for these things, is that every single time you have oxygen, it will have 2 bonds and 4 dots. Anytime you have nitrogen, it will have 3 bonds with 2 dots. Anytime you have carbon, it will be 4 bonds with 0 dots. And if you have fluorine, that'll be 1 bond with 6 dots. And so, based off of this, we know that we have carbons and oxygens that we have to count for. And so this carbon, or this oxygen right here, needs to have 4 dots, and so we add 4 dots to the molecule. And then all of our carbons are happy because they have 4 bonds with 0 dots. And so this is our first isomer of C3H8O. And then I guess step 4 would be to rotate around or move usually the oxygen, nitrogen, or fluorine or other elements outside of carbon around, so that we have now rearranged the order. And so if we look at this order going from left to right for our main chain, we see that our order is CCCO. And so what we could do to make an isomer of this is that instead of it being CCCO, you could make it CCOC as our main chain, and then just make sure that we add hydrogens so that we have honk. And so once again, we look through each of our elements. I'll start from the right. This carbon right here has 1 bond, so it needs an additional 3 more to get to 4. Then we look at this oxygen right here. It has 2 bonds, so it is already satisfied with honk. We look at this carbon right here. It has 2 bonds, so it needs 2 more. And then lastly, this carbon right here has 1 bond, so it needs 3 more to follow honk. And so we've now established that we followed honk. We now have 1, 2, 3 carbons. We have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens and 1 oxygen. So we have C3H8O again. And then lastly, our oxygen needs 4 dots. And so we add 4 dots to our oxygen. 1, 2, 3, 4. And we've now drawn a second loose dot structure of this molecule. The one thing that we have to start thinking about, though, is making sure that they're actually different molecules. And so if you drew something like this, for example, COCC next. So if I asked you to draw 3 isomers and you drew COCC as a molecule, so let me finish this thing up. And we look at this molecule real fast, we'll start noticing that maybe, is this a different molecule or is this the same as something before? And so if we look at this molecule, this is the exact same molecule as the one I just previously drew, so number 2 molecule. And you might be wondering, why is that the case? Well, if you think about this, this is a mirror image of this, right? So let's say that we have a mirror on this side right here, and I guess it would be on the opposite side, which is here. And we counted going from right to left and left to right, and we looked at the direction of that molecule. So we counted and looked at from left to right in its order. And then we looked at this molecule. So let's actually draw that up here. So we go from right to left. We see that the count is the exact same thing, is that we start off with a hydrogen on both sides. Then we have a carbon that has 2 hydrogens up and below it. We have an oxygen in the next position. And then we have a carbon that has 2 hydrogens above and below it. And then our last carbon has 3 hydrogens attached to it on both sides. And so this is what we call, they are mirror images. And so these are the same molecule, not isomers. And so every single time you have to draw isomers, you have to be really careful of this. And so our goal is that we really focus on just looking at it and seeing if they are mirror images of each other. You could also think of it as, you could rotate this molecule 180 degrees, like flipping it over. Like imagine this was on a piece of paper and you flipped it over, it would look the exact same thing as this. And that's our issue with being mirror images, being the same molecule rather than isomers.